Okay. Let's adjust this. Are we dropping frames? I think we're okay. Okay. See if this even makes a difference. I increased the bit rate. Let's see. I think we're okay. Oh, hopefully we're not dropping frames. Alright, I'm gonna mute myself. I think the audio is okay. Okay, we're now live. This is for the record. Switch to live broadcast, yes. All right. Hopefully I have the audio balanced. Can't really tell. I have no idea what correctly balanced audio even is. Okay. Analytics. Stream health. Excellent. Okay. Now, let me see something. If I... I can't really tell. Well, I hope it's okay. I don't really have time. Oh, yeah, I see. It's capped my bitrate. Okay, I'm gonna turn my audio down. Okay. Hopefully, I think that actually should line up with what people hear, if OBS is to be believed. Where is OBS? Hello? I think I have the audio. Okay. I did not really think this through, how I'm gonna switch all this. Pop out chat. And we'll just keep this on top. Keep above others. I'm so professional. Okay. Hello, everyone. We're back again with another radio stream. And this time, hopefully we should make more progress on the schematic. Actually work on the radio instead of build a circuit. So there's the circuit that I built last time. And I can't believe that was 4 months ago. So this time we'll actually get back to the radio, which I have now just unpacked. As many of you know, I am reverse engineering the schematic for this, just for fun. So let me get these, get all our vacuum tubes accounted for. Oh, also, I have new camera set up. So we have an overhead camera. How professional this is. We have my test equipment, at least most of it. I have a camera set up there. I've got my own screen. I've got the Firefox PDF pulled up. I've got KiCad with my schematic. So we are truly living in the age where I am a complete professional streamer. So there's 3 of our 8 vacuum tubes, and here are the other 5. I have no idea which one is which. So I think the first point of order will be to pull up the data sheet on each one of these, just for reference. I think I do remember some of them, I believe. So let me go to my Firefox. Yes, I have to also go to Firefox. Let's see. So here is the Zenith schematic that I am basing this off of. Now this is the wrong one. This is the the Z is the later model. So this would have been the earlier variant, I believe. I think so. So I know that one of these two is the 25Z6. That's our rectifier tube, I think. 25Z6 tube. Right, I think it's this. We could just, yeah, twin diode vacuum tube rectifier. I have this this one over here. Can you all see my mouse pointer? Is it showing up? I think so. It's the 7Q. I have this one. So, in terms of the schematic, that goes here. I've mapped most of this part out already. If I go to KiCad, it's forgot how to zoom. It's here. I forgot how to use KiCad. You're gonna have to bear with me. It's been 4 months. Okay, so yeah, this is this part. Cool. So that's that tube. And then I believe the audio output, I'm not even gonna check. Was it the 25L6? I think it was. Let me check now. The 25L6, yeah, that's the one that's very discolored. 25L6 GT. Oh, perfect. Yeah, so that's the audio output. Designed for use audio frequency power output stage of radio and television receivers. So that's that one. I don't think I have that one in the schematic yet. It's where it would be like over here. Oh no, I do. Yeah, okay, I did map this part out for some reason. I wonder why I'm starting. Oh well, I don't know, I'll figure that out later. I have to go back through all of this anyway later in the stream, so. Trying now, figuring out. Okay, so then the rest of the tubes, we have 2 identical tubes, I think. 6SB7? Oh wait, no, 6SH7. We have 2 of these. So I'm going to rearrange these. So we have them in order. So we got our rectifier, audio output. We've got 2 6SH7s. Let's go ahead and see what those ones are. 6SH7. No, these are the radio frequency RF amplifiers. So these are what, like the first and second IF? No. We have second IF and limiter. Oh man, it's been so long since I've looked at the circuit. I don't understand what's going on anymore. This is so sad. Okay, so we have those. We've got our 6SG7. Let's just pull this one up as well. That would be, was that the RCA tube? 6SG7. Yeah, it's RCA. Okay. Actually, you know what? I'm going to arrange this. I'm going to be very smart. I'm going to arrange this in the exact same way it is in the schematic that I have. So we have rectifier, audio output is here. we've got the 6SH7 right before that. Second IF, the other 6SH7. 6SG7, that's the first IF. And then, let's see, we have the 6SB7. Oh no, I'm missing this one here. 6S8GT. 6S8GT. Right, this is the detector, I think. Discriminator detector first audio amplifier. So it's both. Okay, so this one actually goes. I have to move all of these down one. Sorry, I just also realized I need to change the title of the stream. Bear with me 1 second. Okay, hang on. Okay, we're fine. Stream, edit. Okay. Vacuum tube radio. Okay, I need to back on the Zenith. Come hang out. I'll be and chill. Come hang out and chill. Save. Okay, there we go. I'm so professional. All right, change the title of the stream. Okay, where was I? Firefox. Okay, here we go. Right, so we have our triode. Okay, and the last one is the 6SB7. 6SB7. This is the converter tube. So I got a notification on my phone. Nope, that is not the datasheet. Okay, pentagrid converter. Yep, and then we have, let me move that one in place. That's this one. Right. Okay. 6SB7. It's our converter tube, and then we have the RF input amplifier, which is, oh gosh, I don't even remember. It's illegible, but I'll go look at the data sheet for this. It was the 6AG5. 6AG5. Oh, okay, there we go. RF pentode. All right, so that's all data sheets pulled up. We've got our schematic here, and I have everything I need, I think. So I guess now we're just going to look through the schematic and figure out. I'm going to keep these in the same order I found them in. Actually, I probably should put these back in bubble wrap, shouldn't I? Vacuum tube radio stuff. All right, there's our rectifier. Got our audio output. Detector. Limiter, whatever that means. It's like the third audio. Got second audio, first audio. Mixer converter, an RF amp. Keep those in exactly the same order. Okay. Gotta turn the music down a little bit. Okay. So now let's go ahead and bring the radio over. I have, again, not touched this in 4 months. So I am going to have to figure out how the circuit works again, and also how everything's connected, because I know I intentionally disconnected some things. I have to figure out exactly what I've changed. How is that? Is that centered? That's the wrong way. Is that coming across okay? It does not look great. Okay, well. Oh, I've tried so hard with the stream quality. It's just impossible sometimes. Okay, well, I think that looks okay. So, that's our radio. Yippee. Let's go and look at KiCad. Right, so I have to figure all this out again. And it's really hard because the schematic is like all the way over there. I have to keep walking back. Okay, so we got our power plug here. And I'll pull up OBS again. You know what? It doesn't really matter. Actually, it does matter. I'm going to do it. Okay. You know what? I should probably just actually do a split screen here. Wait. What happens if I do Firefox now? Or KiCad? Oh, okay. Yeah, well, it's whatever. I'll figure it out. Okay. So, let's see. Okay, we got power plug here. So that's at the back. And then according to the schematic, that comes along over. We got our power switch here, which I believe, okay, so I don't want to block this. One side of this gets, what is this, connected to ground? Or connected to the chassis. Okay, yeah, I see. So, yeah, I see. So it goes through the power switch to the chassis. Let me just check out that power switch real quick. Make sure it still works. Ground or chassis, I guess. This is the other one. So you want this one, and you want it on beeper mode, which it is. So if I turn this, oh my gosh, it's frozen. Wow, that is actually really tough to turn. It should have clicked. It did not click. Okay. All right, we are connected. I don't know. Our power switch seems to have stopped working. It's not entirely unexpected, but... Oh, hang on. Ah, it is. Okay, so we do have a bad power switch. I have to kind of shake it around a little bit. Okay, well now it seems to be working. I mean, I guess you're going to have like, what, 120 volts AC on this, so it's probably going to work. It does seem to be kind of high resistance though, I'm not going to lie. We go into ohms. Okay, that one's like, what, 7 ohms. If there's anyone in the chat right now, probably don't like that. Yeah, this is not good. I'm just like moving the power switch back and forth. 150K. Well, the power switch is also the volume control, so That's really not great. There's a tone knob here as well that is also kind of in bad shape. So we do have a bad power switch. Kind of a semi-bad power switch. It might actually work at a higher voltage, though I'm not really 100% sure. Okay, well, that's unfortunate, but it is what it is. Yep, it is what it is. So, well, pick this off. All right, what's the next one? Let's look. That's the wrong thing. Nope, KiCad. It's a problem with streaming on Linux. It's a problem sometimes. Okay, so we have a 20 nanofarad capacitor. Okay, so that's going to be one that I've already replaced, I believe. So right, this is this wire here. We go over to here, I think. Let me just double check. Where is this capacitor goes? Oh, I see. The capacitor goes from there to ground. So okay, so this one right here is 100 picofarad, and this is a mica capacitor, so we don't need to do anything with that. Then okay, so then we have this wire that I need to replace at some point. Probably should do that now, honestly. We have an RF choke, and that goes down to here. And that, I believe, is the start of the filament string. No. Okay, so this goes up to right here. We go up to the rectifier. This pin and this pin are both pins of the rectifier. We have nothing else in the way. So that must mean that this capacitor here is our 20 nanofarad. No, it's not. That says 47. Wait, where's the 20 nanofarad? Where did I put it somewhere. 20 nanofarad to ground after the choke. That's so strange. Where? That's not this one. It's after the choke. I see a 473, which I thought... Let me measure it, I guess. I swear, I thought that was it's 47 nanofarad. It is 49 nanofarad. Here, I'll show you guys. Huh. That's strange. So you can see the one I'm looking at is here. I thought this was 47. Fascinating. Unless... Am I in the way? I can't tell if it is in the way of the thing. This is gonna be just a learning stream right now, because I'm, like, just trying to, figure out... Okay. No, nothing's connected here. Let's figure out where this wire goes. Okay, there is a resistor. Can we go KiCad again? Oh, it says 20 nanofarad. Did I make a mistake? I guess I could just consult the guide or the whatever this thing. Oh man. Okay, yeah, it looks like it says 50 here. Did I make a mistake in my schematic? No. No, surely not. Huh? Okay, I'm assuming I made a mistake. I'm changing this to 50. I assume that's what I'm doing here. Alright, it's now 50. That doesn't make any sense to me. I'm gonna double check that. Okay. Alright, we have 50. Coming from there, the choke, after that to ground. Yeah. Yeah, it does seem like I made a mistake there. That's not 20, that's 50. And I replaced it with a 47. Which is fine, but okay, so that is that. I'm not crazy, that is that one. Okay. So there's a mistake in the GitHub schematic. I'm sorry. 25Z6 GTS rectifier, so we have that. Let me just check out the filament string. So we got our 2 lamps here. Let me just see here. Okay, so one of these wires should go. It's this one here. It should go up to the lamp. It goes to one side of the ohmite resistor. Let's see. Okay, so all right, so we got our wire there. Okay. I think I see what's going on here. Maybe. Okay. I'm gonna flip this over. Okay, so let's look at the top. Right, so we got our 2 lamps should be in series. Yep. Okay, we got a yellow wire here. Goes up to here. We got a black wire to here. And then a yellow wire back. So it's the 2 yellow wires on the bottom. The lamps are in series and they both work. I did power them on, as you all saw in the TikTok. Oh my goodness. I'm trying to frame this right. There we go. Let's go in a little bit more. So okay. Should back out a little bit. Okay. All right, so we have this here. So one of the yellow wires is on this side. That's correct. The other one goes to 30, and then this is the 67. The lamps are in series, so it should match the schematic pretty much entirely. Yeah, and they connect back in the middle part, and then 6, 7 goes to the filament string. 6, 7, all right. Okay. Yeah, oh yeah, I see. This is the return wire, this yellow one here. Or I guess they both go here, so. This right here is to the filament string, and okay, I'm so glad I found this. I intentionally disconnected this. I don't really remember why, but I did. Sorry, can you all see that? It is this wire right here that I disconnected. So, I'll have to figure out where that went. The downside of disconnecting things. Okay. Let's see. So this one should go back to the filament of the rectifier tube first. And that should be pin 2. So if I count this, I don't even remember where you're supposed to count the pins from. Oh, from the notch, I suppose. So 1, 2. You know, I can't tell if that's counterclockwise or clockwise. I forgot how this works. Oh, I see. It was definitely this pin right here. It's the only one it can reach. Here. So then the heater goes across here. This must be pin 2. This is pin 7. And then from there it goes somewhere. I actually really cannot tell. Oh, I see. Okay, it's this cable here. All right, well, let me ohm all of this out just to make sure I'm not crazy. Let's go to beeper mode. Okay, so from here to where is it supposed to go? Actually, I don't remember. It's supposed to go to the 26L GT or 25L L6, which would be one of these tubes. That doesn't really help saying it's one of these tubes. Okay, it's that one. There, found it. All right. Oh my gosh, stay on. Well, it doesn't need to stay on actually. Okay, so there's that. So that's pin 2 again. So we go to this one here. This is pin 7. I'm going to switch out these alligator cables for proper probes. Just give me 1 second. I hope I have some probes. Multimeters. Open this drawer. Got multimeters in here. Multimeters. Here we go. Okay. All right. Oh shoot. That is that's broken. I need this one. Got a match pair of multimeters. That's very important. Or probes, I guess. Alright, so out with the alligator clips and with the proper probes, because I can't reach down that far. Let's do that right now. Okay, I'm back to beeper mode. Let's test this out. Okay. So we went from here to here? Where was it? I might not be making good contact. These probes aren't very sharp. Sorry, I'm going to figure this out. Okay, no, it was the wrong one. Okay, so that means this one here is the other one. So we'll just keep that in there for right now. Okay, I just realized I had the chat in the wrong mode. Whoops. Sorry, guys. Oh my, I'm a little bit tired. Okay, so let's do this again. Firefox. And the next one's the 6SB7, and we also have looks like a mica for 475 picofarad. Is that true? Is it 475 picofarads? Oh, wow, look at that. Take a look at this, guys. From that filament pin to case, 459. So, pretty close. And I believe it's mica. I don't think it's there. Like I don't think it's there. I think it's it's actually so hard for me to tell. Holy. All right, sorry guys. The lighting is about to change. I need to see though. Okay, it looks like, oh, I think I see it. It might be that domino right there. No? Well, maybe not. Okay, cannot tell. Is it the red? No. It's like this kind of like, it's this wire here, I think. Bro, I cannot see. Oh, okay. It looks like it ends right here. I mean, this is actually true. This is kind of insane. Is this the actual filament? Put this back in beeper mode. Okay, no, it's not. I followed the wrong wire. It's this one here. Oh, it might be this one, actually. Ah, it is. It was this capacitor here. Okay, so... I see. Okay, then this one comes down. Ah, this makes so much sense. I mean, it really doesn't make any sense because this is who designed this. But, okay, so that's like, what, pin 7 on the other one? Yeah, I'm right. Wow. All right, 6SP7, then it's pin 2 again. So then it's pin 2 to the 6AG5, which is the small tube. Okay, so that's where that's, I don't even know where that socket is. Oh, it's right here. Okay. Man, I'm never gonna figure this out. I don't know. You know, I wonder if it actually could be this other one. It's actually so hard for me to do this, but... Okay, it's gonna be this. Wow, I don't know if this is gonna stretch that far, but... Yeah, I think that's right, and then... Okay, well, this has to get out of the way. First and foremost. Alright, there we go. Yeah, I don't think I can even reach that. I'm going to just trust that that's connected. I don't think I was able to reach that before. All right, then we have another one from 3 to 2, and then I'll just measure from 2 to 6SG7. Let me see. I think it's this one here. Like if this goes to this pin here, yeah, it's this one. So this to here should be for another 475. Another 475. So let's see if that's actually true. One on here, the other one on the case. Maybe adding a little bit of capacitance, I'm sorry. This one's slightly overvalued, but you know, it's probably fine. Okay, so then from here we have 2 to 7, then we have, okay, this is important. So these two I probably replaced. The 6SG7 to the 6SH7, there's a 50 nanofarad that I probably replaced. So that was here to here, and yes, this is the 50 nanofarad that I replaced. Okay, so then from here to here, that is the other one. What was that? The 6SH7, yep. Then that goes to pin 2, and then from 2 to 2 we have a 1 nanofarad that I think I also replaced. And the other one is another 6SH7. So where there was this wire to here to here. Okay, that's this gray wire. I can't tell if is that actually connected? Oh, I'm not in beeper mode. Okay, that is. And then this must be the 1 nanofarad that I replaced. Just gonna fold it back up. Let's take a look at it. I realize I'm not on the overhead camera. My apologies. This one right here. 1 nanofarad. Yep. Okay. Put the light at a good angle again. Okay. Fold this back down. That's probably enough out of the way. Okay, then I think we have what, from 2 to 7, we need to go from to the 6SHET, which is like the tube that's like out here, I think. Or maybe it's, you know, it's probably the one that's back here, you know? I think it is this one. So we need to go from this pin here, which is pin 7, to this one, and they are connected, and then this should be ground. It is ground. That is great. That is really good, actually. Okay, so that's everything taken care of there. That's the whole filament chain and all the capacitors accounted for. Oh man. Sorry, I am a little bit tired. Okay, so now I should probably go back to figuring out the rest of the circuit, huh? Okay. Well, let's do that. Let's go to a KiCad. I say 2 filament string, but I don't actually have the filament string. Like,
And whoever goes too deep into this has his share of that curse.
I don't actually have that here. I just realized I don't have
In anger. Even the stars up here in the sky look like a man.
It's fine.
Taking a close look at what's around us, there is some sort of a harmony.
Okay, we have 22, which is the one I've disconnected, and then 40. Okay, so this is where that giant capacitor comes in.
It is not that I hate it, I love it. I love it.
This one here is the resistor I disconnected.
I love it against my better judgment.
This went, at one point, it went to the plate of this tube. Or, I'm sorry, it went to the cathode. And both are connected together, so it just puts both diodes in parallel. So, I wonder. Those are pins 4 and 8. So, let's go ahead and look. I really need a stream deck so I can switch this remotely. We got 1, 2, 3, 4. Oh, sorry, wait. 1, 2, 3, 4. Or maybe 1, 2, 3, 4. Yeah, 5, 6, 7, 8. Okay, here we go. Yeah. This one and this. Okay, and they connect it up to that. Okay, so this is what I've figured out so far. I don't want to break this resistor. I should probably make sure it still works. Whoops, I dropped my probe. Alright, what are we measuring? I don't want to bother showing you guys, but I can't get a good connection. $22.6 ohms. That's pretty close to 22. Huh. Okay, so that one connects up to here. Oh, that is the wrong thing. And then this one connects over to the capacitor. Okay, that's about as much information as I have. So it went up to one of these, and I think it connected up to here. I believe that's true. Because this orange wire that leaves here goes over to the capacitor. And then this red wire goes over to the permanent, was it the field coil? Yeah. That's the field coil. Let me measure what it's what the capacitor is again. Very cautious about this because normally you replace electrolytic capacitors in gear this old, but hey, this one tests pretty okay. Any voltage on it? Minus 0.3, okay. I wonder, can I do a capacitance measurement with this? Can this even measure? Should be 40 microfarad. Measuring 52. This section measuring 48. This section measuring 75. Darn. I really do want to reform it. Like, I did reform it. That's the thing. I did reform it, and the values are all back to what they were before, which is really bad. The only way to... So I got rid of all the high voltage power supplies that I was using because I was pumping DC voltage into them. which was like a really smart way of doing it, but since I don't have that anymore, technically I do. Technically I have enough power or enough voltage to do it, but I'd rather like try to feed AC into the rectifier and see if it reforms that capacitor or not. Huh. I wonder. But in order to do that, you need all of the tubes in there. At this point, it's just like a question of like whether or not I even want to power this up. You know what? I'm gonna cross that bridge when I come to it. And I may have an ace up my sleeve for that because I do finally have a current limiting source. But still, I mean, like, even with like what? Even with the 65-watt light bulb. Well, first of all, even with the 65-watt light bulb, it's definitely not going to be enough because what does this radio draw? 80 watts? What does this radio draw? Is it 80 watts? Oh, man. It says on here somewhere. I think it said how much power this drew. Really? Huh. Is it not? Is it not on the case? Where's the tube chart? I have the tube chart here. It's gonna be underneath this, I think. I don't want to get asbestos on myself. I don't. For some weird reason, I don't have the tube chart anymore, and that's a little bit concerning because I thought I had that. That's a problem, isn't it? I'm gonna stand on this chair 1 second, guys. No, it's not up there either. Am I just crazy? This radio did come with a tube chart. Where did I put it? Might be at my house, honestly. Could have gotten mixed up with a bunch of other stuff. Yeah. Oh, man. Okay, well, time to continue on reverse engineering this. Okay. All right, well, make sure that's centered. Well, let's continue. We got our speaker, right? So we have our permanent, or our voice coil. And we have our other capacitor. Which, okay, I think I know where that comes through. Just taking a look at this in my mind so I can figure it out. 20 nanofarads, I probably replaced that. Okay, I think I'm good. Still gonna bring up the thing though. Alright, back on here. This was our first section. I think... actually don't remember. It's so sad. All right, I'm gonna have to flip this over. Right, so it's the red, so it's 2 black wires. One of them goes to the other side. One of them goes to the 20 nanofarad. Which might be this one here, actually. No, that's a 10. Oh, you know what? It might be this one. I'm actually just like kind of like thinking very hard right now. Just, where is this wire coming from? Oh, good. That's asbestos right there. Awesome. Fat. Go clean this off. No, actually, I think that's just a cobweb. Yeah, never mind. Oh man, it's so hard for me to see here, though. Oh, you know what? I see what's going on here. Yeah, no, this is this part. It's attached up to this part of the tube. Yeah, the plate of the audio output tube. Okay. I see what's going on here. So it's this thing that I've disconnected is the other return from this. And if I remember correctly, I think it goes here. Because then this is the wire, this red wire, yeah, that wraps all the way around to here. Well, no, it doesn't wrap all the way around, it just wraps part of the way around, but... Alright, I think it's high time that I start soldering some of this stuff back. Because at the end of the day, like, there's not really a lot I can do about, trying to protect, like, the tubes in this. Really just have to power it up with a dim bulb, and then just hope nothing explodes. Sorry for yawning so much. I know I've said it before, but I'm very tired. I was gonna stream until 12, but I might just like... No, you know what? I'll probably stream till like 11 or 12 still. We haven't really gotten to the juicy part of the stream yet, which is replacing all the capacitors. How is my stream doing? Is anyone here? Stream health. Healthy, alright. Privacy is public. I wonder... Stream URL. Alright. Oh, sorry, darn it. That's not the right thing I want to do. Alright, give me a second, guys. I'm gonna... I am going to... Okay, no, we did have a couple of viewers come in. Alright, well, awesome. I was like, I wonder if my stream is even public. No, it is public. I am currently live. Okay. Well, all right. What am I doing here? Let's try going back to this. Okay. So, oh man. All right, yeah. Let's just forget about safety, or let's forget about let's not forget about safety. All right. Out of context. Don't take that out of context. But let's forget about radio safety here for a second and just kind of solder everything back, because there's no way I'm like gonna say, like, if part of this blows up, it blows up. So I had all this stuff in mind, like, well, I can power the radio up in sections, but like it's just gonna be too complex. I might as well just blanket replace capacitors and then power it up on a dim bulb. All right, so solder, right? Solder. I was like, where did my solder go? I'm gonna use the large stuff. Large core solder. Oh. Okay. So where's the first thing I want to fix? I have I at least have 3 different things to solder. Probably 4. And the last one, I probably am going to change how I do it. I'll probably ask chat whether or not I should replace a wax capacitor that checks to be in good health, but is very bad if it fails. And I need my tool here, which means I need my tool bag. And I really do not want to break this. Like, this is like very important not to break this particular resistor, because it's both high wattage and perfectly healthy. Okay, there we go. So we want to solder this back onto here. Wow, why does that feel so, I probably should turn on the fume extractor before I do this. Top 10 good ideas ever. But then how would I frame it in the shot? So we're gonna just, like, oop, I started melting the wax capacitor. That's really bad. Let's not do that again. All right. I'm actually going to use the fume extractor now. This is getting kind of smoky. How am I going to frame this in shot? I guess I could do this. No, that looks terrible. Here, we're gonna put it, go around, put it here. That'll at least be somewhat helpful. Wow, okay, no, I didn't. I was gonna say, like, this soldering iron is not working out for me. Oh my goodness. Just smoking, bro. Man, I cannot get that to stick for the life of me. I'm actually going to turn down the heat, though. I'm going to turn this down to 375. And I'm going to clean it. So I think there was plastic on this at one point. I'm going to use my other hand, actually. You know, I probably should just, like... My earbuds keep disconnecting for some reason. I don't really know why. What's going on with that, but... Okay. I can't tell if this is working or not. Wow, this is like, this does not want to resolder. That's crazy. I have never had more trouble soldering. Well, that's not true. I mean, it's like kind of on there, but it's not really on there, and I don't like half done solder jobs. This soldering iron's kind of been through it. This is my personal soldering iron that people have been borrowing. It's all the bad sign when the heat is cranked up really high on one. It's like people don't clean them and then just keep cranking up the heat. It's like, oh, why is my solder not melting? Just like destroys it. Man, I cannot get that to solder. That's crazy. Surely this... I guess I can go up to 400. I don't like doing this. Okay, that was kind of the ticket. Oh gosh. Maybe the ticket. I'm gonna just grab this. I just accidentally bring the wax capacitor right next to it again. Whoops. There we go. I think that's on there. I think. I mean, it doesn't look good. Whatever. This whole radio is pretty much whatever. That was really hard to melt. I think my iron is dying. Okay. 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 Alright, what's the next thing I need to reattach? It's this one here, right? And I think so. I also need to replace this wire here. I'm gonna do that actually sooner rather than later. I mean, that's just so dangerous. Like, the wires that were actually covered in fabric and not like decaying plastic are actually like surviving, like this one. But yeah, the rest of the wires, yeah, pretty much good luck. I would never trust to run this without a current limiting source. Like, this is really bad. Alright, I think this is where it attaches, so I'm going to strip this wire, maybe. How do I even strip a wire like this that's covered in fabric? Okay, it's like, what is going on? I have no idea how to do this. It's probably painfully obvious, but okay, well, I got part of the fabric off, but there's still... What is this, paper? Yes, it is. Wow. Wire is covered in paper. Or like string. And then that is wrapped in fabric. That's so interesting. I hope this is string and not some sort of poisonous thing. There's already asbestos in this radio. What else could there be? That's really cool. Look at that. String covered wire. Who knew? Alright, we're gonna solder that to there. Again, this is just so... It's just not hot enough. Huh. Okay, well... Proving very difficult. I don't remember it being this difficult to solder onto this. Dang, okay, that's kind of crazy. I'm trying to get this down into like a position where it's gonna solder correctly or well at all. It's kind of like a balancing act I'm playing right now. I'm trying to balance this wire in place. Just hold it down there. Yeah, perfect. Okay. You know what I'm beginning to think, guys? I'm beginning to think my soldering iron tip is busted. Do I have a way to clean this that's good? Okay, not bad. I cleaned it a little bit. And it stopped working again. Alright, well, I guess I'm just gonna say screw it and, go up to 425. Why not? Yeah, beat them, join them. I did not think I'd be spending most of the stream trying to solder like 2 wires back. It's crazy. These do not want to solder. Crazy. I mean, I don't think I can turn this iron up much more than this. And the string is over everything. Oh my gosh, so annoying. I don't think I can get rid of this if I wanted to. I do want to. Oh my goodness, this is so problematic. Okay, there we go. I got rid of some of the string. Oh, but now there's more. How can I cut this any better? There we go. Okay. All I've done is like lower the amount of solder on this joint. Like solder is just falling off this. It does not get hot enough. At all. Oh my gosh. Whoa. Man, I do not know. That's crazy to me that I cannot solder onto this. What is in this joint? Okay, there we go. I kind of had to hit it from the back. No, never mind. It's just... solder's just like crumbling. I mean, I guess it is just like pure lead infused, whatever. Man, this is actually really difficult. I gotta keep this in mind. Do not ever desolder anything else from this radio, because holy moly, this is too It's like the new solder doesn't want to mix with the old solder for whatever reason. Even though they're both leaded solder. You should probably double check that actually. Oh, it fell off. Oh. This is leaded, right? The stuff. Yeah, 6337. Yeah, it is. I was like, I did not buy lead-free solder. Oh man, this is so annoying. I understand how annoying this is. I've spent 30 minutes trying to solder a piece of wire. Twist all the wires together. There's plenty of solder and flux on this. I just cannot attach this, for whatever reason, to this metal here. Okay, wait. I think I may have gotten it. That is actually crazy and smells so bad. That smells terrible. I'm so glad I have this ventilator. Oh my gosh. Okay, well, it's actually on there pretty well, I think. Oh my goodness. That was an ordeal. Alright. That is not a good look for how these other ones are about to go. Alright, you know what? I don't even know if I want to do that one next. I think I'm going to replace this wire here. Because it's frayed and falling apart and a fire hazard. Oh yeah, I want to also do this one here. Actually, let's do this one first. This one gets soldered onto here, if I'm not mistaken. First you have to just like absolutely like lay on the freaking heat onto this thing. So it's even like remotely accepting of your probably turn that ventilator back on, huh? I think I'm going to. Holy moly, that's strong. Oh yeah, that's old school flux that's bubbling up. It's like yellow colored. Disgusting. All this was hand soldered, by the way, which is actually just incredible to me. My goodness. Okay, we got that one in, hopefully, I think. Hopefully, I think maybe. Okay, yep, we did. Alright. Base. Let's cut this one off. Get better wire cutters. Once I replace this one and then solder the other two, I'm going to take a 10-minute break. Then we can get back to reverse engineering new parts of the circuit. And potentially replace a few more capacitors. And then if I'm really feeling like it, I'll stream again tomorrow night. Look at that. Can you all see that? That is one frayed wire. Look at that. That is crazy. That's just like decayed insulation. This is like plastic. The fabric covered wires are doing all right, but not these plastic ones. These are in rough shape. Very rough shape. So we're gonna need a replacement for that. Alright, this is when the whole stream could shut down, because I'm moving the drawer with my laptop on it. Okay, that's solder. Where's wire? Need some wire. I'll be very careful. Okay, perfect. Look at this. We got brown wire right here. Exactly matching the old stuff. Cut off approximately same length. Okay, we put this back very carefully so we don't disrupt the capture card. All right. So there we go. Old wire, new wire. So looks pretty good. I'm gonna strip this. I'm keeping like all of the old things I replace in like one place so you can see everything that needed to go when I get this working fully. Okay, let's see. Yeah, that should be okay. All right. Gotta solder to this one first. Turn the thing back on. I'm gonna put more additional solder on here. I realize I probably am like blocking. No, I can't really tell if that's soldered correctly or not, but I almost just don't care at this point. I do realize this is like definitely not the breathe on. Huh. And yet I'm still somehow breathing it in. Fume thing is on full blast. Ah, so annoying because it just crumbles. It doesn't stick. I've never seen this before. I mean, I have seen this before when I use, like, you know, if you ever used, like, lead solder and mixed it with lead-free, then you've seen this behavior, but I'm using leaded solder, and this stuff in here should also be leaded solder. But for some reason, they just do not want to mix. I can't tell if my iron isn't hot enough. It just kind of like cakes off. It's the weirdest thing. It will eventually work. Oh my gosh, look at that. That whole thing flew off. I have never seen. Did you just see that? This whole piece of solder like fell off from like the metal. It's not bonding to this. What? I don't know why. I've never seen this. Well, now I'm soldering directly onto the tab for all the solder blob that was here just like slid off as soon as it cooled. Okay, I'll try this again with my solder. It's much more like a expected behavior here. Oh my gosh, yeah, does not want to stick. I have a feeling this is not going to help, but I'll try and use a bit of flux. This is not going to help anything, but okay, you know what? Actually, I take it back. That helped a lot. I don't really get it because the solder I'm using has flux in it. But maybe it's just not really good flux. I am gonna make this joint a little bit better though. My gosh, it's so bad. There we go. Okay, that's like a somewhat acceptable solder joint. It's really bad solder joint, but it's like barely passing. I have never had this much trouble soldering stuff before. This is a little bit crazy to me. Okay, well, now that this wire is replaced, it's less of a fire hazard. That's great. Sorry if I haven't said much. I'm looking at what in the earth is going on here. Right, so this is the other one, right? So that's this thing here with the flux back up top. Zoom in. Zoom. I can't really see what exactly I'm working on, so I'll move it over a little bit. And actually, I am getting quite tired, so I'm gonna sit down for a second while I look at this. My goodness. That's how badly those fumes are. I'm sneezing. Oh my gosh. Okay, let's see here. I don't. Okay, so this is that thing, and this comes over from there. But it doesn't really tell me anything. Where, like, I'm pretty sure this one is supposed to go to this one, and then this one is supposed to go to this one. Because if I look at this, which is this wire here, it's attached. It looks like it's attached there, and then that would be pin one of that tube here, and I don't even remember what that tube is, but it's the one I put in the schematic, I think. So wait, really? Where's the other one? This other one is connected to pin 4. Oh, I'm sorry. No. Pin 8. Okay, no, that would actually make sense. Never mind. This is probably pin 8, not pin 1. Audio output 2, pin 8. So that would make this one would want to connect over to here, because this is the one that measured was it 70 microfarads, I think. I think this is the one that measured that. 70 microfarads. Sorry for the camera angle changing. I moved my laptop back. Man, those fumes really bothered me. So one that's 75. Yeah, okay, so this is the one that's the lower voltage one, I think. Alright, well, that makes sense. Okay, so somehow we need to get this. Move this back a little more. We need to get this soldered. Sorry. This soldered here. And then this wire soldered here. I don't really know how I'm going to be able to do that because that's very tricky. This wire almost doesn't reach. Like, it kind of does, but I think I'm going to do this one last. And if I need to, I might run a wire extension from here to the other place, to here. So let me start by taking this wire. Well, that broke off. That's how decaying this insulation is. I hope this isn't going to cause a short circuit. Actually, I really do hope this is not going to short. Alright, well, I'm going to try to do my best attempt to J-hook this in place. Pretty bad attempt, but... Alright, there we go. Looks pretty good. Check it out. Oh, wrong way. Right there. Very nice. Now we just need to solder it and have it not be terrible. I am actually super tempted to put flux on this again. Okay, did the last one. Do just a little bit of flux. I just realized how much smoke this is giving off. It's kind of insane. You know, I cannot tell if that's soldered. Alright, well, I think that's okay. Actually, I don't know if it's okay. We're about to test if it's okay. Well, you know what? It might be okay, guys. Check that out. It's not something you see every day. Me getting a good solder joint in the first try. Actually, it's a pretty good solder joint. Gotta be honest, it's not great. The thing is, do I want to try to fix it? There's so much smoke. I think it's okay. I'm gonna assume it's okay. I'm gonna give it a good couple yanks. But I also don't want to really yank it because the insulation is so frayed. Okay, you know what? I think it's good. I'm gonna call it okay. Man, okay, you know what? I'm gonna run an extension wire. This is it's just so tiny, I guess you could say. But it just deserves an extension wire. So we need to cut one. Put this over here with the rest. Cut a piece of this like black colored wire. Okay. Let's check this out. There we go. Now we just need to somehow make a good connection onto this. That's like much easier said than done. Okay, there we go, I think. Ouch, I almost cut myself. Okay, now it's J-hooked. Let's try to solder this. Oh, it fell off. Oh, great. Okay, let's try and solder this. This should actually be relatively easy to solder since it's such a small thermal mass. See, that's how soldering is supposed to go. Oh, it didn't actually work, never mind. Okay, there we go. That's how soldering is supposed to go. It's supposed to be that quick. Not like, man, soldering to these old radios is actually kind of a pain. Pain in the real butt, bro. I don't really even know how this helps me. I don't even think it does. Soldering to this tab is just gonna be a pain no matter what. Oh my gosh, that was disgusting. It's bubbling. Oh, there we go. You know what? I cannot tell if this is working or not. But, certainly is doing something. Okay, there we go. That was like pretty short-lived. I'm gonna do this. I'm gonna pull it through like that. What I'm gonna do is I'm gonna grab from the other side and I'm gonna twist it up so they actually have a good secure connection. And that actually might have just made a difference. Okay, there's some more decaying insulation coming off this one. Drop that down in there. Fumbling away to nothing. Okay, well now we have a somewhat kind of secure-ish connection. And let me see if I can... I think I'm going to tilt it like this. I know you all are not going to get a great view of this, so I'm going to try and be quick. I'm going to move this over here. I'll try to get a good lighting shot up in here where I'm working. Actually, that just is terrible. It's shining a light right in my eyes. Oh, you know, that was perfect. Can't believe it's staying like that. Okay, this is the problem. Gonna just put this smoke thing on top. I know how stupid this looks, but I'm gonna set off the fire alarm if I'm not careful with the amount of smoke that's being released here. Oh wow, you know what? I think I actually got it. Dang. That's crazy. That's a really secure connection. Let's go. How many hours into a stream, and I've reconnected all the wires that I disconnected 4 months ago. That is progress. All right, I'm gonna take 10 or 5 or however long, and I'm gonna make a cup of tea. And that's all the stuff we connected, right? So when I come back, we can go ahead and delve deeper into the schematics. And have a great time. All right, I'm gonna take 5. Put up message. Here we go. Yeah, you get to look at the radio, not at a black screen. All right, I'm gonna take 5. Oh, I'm also gonna restart. I'll put on some more music for y'all. You can definitely tell what my favorite game is, can't you?
Okay. Let's see.
You win. All right, wow. Got a nice cup of tea. I'm actually gonna leave the volume there, turn it down here. How's the balance? Hello? I think the balance is okay, actually. Turn this down a little bit more. Wow, that tea is really hot. Check it out. Some lemon tea. Because it's, what is it, 10 o'clock? Yep, it's almost 10 p.m. for me, at least. So I'm on the East Coast. East Coast, baby. Alright. So, let's see. We have everything reattached that I had disconnected, but we're probably going to take some more stuff out. We know the power switch is going to be a problem. And I think it's time to get back to reverse engineering this. So, all right, we discovered all this. None of this stuff is connected to a tube socket, so I'm going to just quickly go through this. We got R4, which is from one side of the speaker, it looks like. That comes over here. Right, so if I go to R4, we just need to flip this over because it comes from one side of the speaker. This really makes no sense to me, but it's okay. So it's one of these yellow wires. Okay. Trying to get a better light situation here. This light is being a problem. Okay, so it's somewhere here. It's one of these wires. Where's my screwdriver that it's pointing with? There we go. Let's see. Yellow and yellow go here. It's like this orange-ish colored one. Was it? No, it's this yellow one here. Okay, so that was the 2.2 mega ohm. right? And then this goes to the other side. All right, so that lines up what we have. Okay, and then we got 20, no. Yeah, 20 nanofarads ground. And then 4.47K. I already spot the 47K, it's right there. And this is our 20. Because this is ground. This must be ground here. That's so dangerous having that like right by the other thing. It's gonna be problematic at best. Let me just verify that that is ground. Take our beeper. Put our solder away. Let's do that first. Okay, let's see. This should be ground. It is. Okay, so this is our 20 nanofarad. I can't even read the value, but I replaced it, so I believe myself that it's 20 nanofarad. Let's see what the Firefox schematic says. Oh, went too far. All right. Oh my gosh, where even is this? It would be this one here. Yeah, it's so different. This schematic is so different. It's so different that I wonder if someone's like messing with me and just put together one that made no sense. Then we got 50 nanofarads. That goes to the pot case. From ground to the pot case. Okay, that would be, which one is that? Is that's not this one, is it? This one here. What does this say? That's 10. Oh, it's this one here. Oh, that's so strange. That is weird that this is the pot case. I mean, I think I must have measured this, right? Did I ever do this? Did I ever leak check this? That is voltage. What are we measuring here? 70. I just realized I don't have any of my equipment to test to leak check stuff. Turn off my soldering iron. Okay. My goodness. It's so corroded, it's crazy. 73 nanofarads is what I'm consistently measuring. Now, chat, is it worth replacing this or not? Is it worth replacing that 50 that's measuring 70? I don't know. But yeah, what voltage is even going to be on this? Surely not. Like, the only voltage that could be here. Wow, 2.2 mega ohm. That is such a high resistance. This circuit makes no sense. This circuit really does make no sense to me. Let me go to the Firefox one real quick. Oh man. Got a capacitor there instead of a resistor. You got your 20 to ground, you got your, this is 4.7K instead of that. I'm sorry, this is 2.2 mega ohm, and then this is 47K, which is the same, because 47M is actually 47K. They changed this value, it's 2.2. They got rid of this resistor. This is 0.5 to ground. This is all still the same. So yeah, I don't even know what. That's ground, that's ground. This is like probably pretty close to ground. Bro, this, oh man, this circuit is giving me nightmares. Like, can someone please explain to me what this potentiometer is doing? Like, what even is this? I'm counting 1, 2, 3, 4 points, and then a grounded case. I'm sorry, not even a grounded case. Capacitor attached to the case. What on earth is going on there? Then if we come over to the actual potentiometer, which is here. Sorry, you can't even see it. Like, I'm counting, this is the case, right? You got 1, 2 for the power switch, because the switch is built in. And then you have 1, 2, 3, and then 4. What? I do not get that. I do not understand what this is doing. I do not get this at all. Someone help me. I did my best here. Oh wait, yeah, oh yeah, that's right. My best guess was that this is like a divider, not a double pot. I did write that. I was very confident with that. I said pot midpoint. R13. What is R13? It just says, no, this is 2.5 mega ohm volume control. What even is this? Like, I'm good at reading schematics. I do not understand this. My best guess is that this is like, actually, wait. No, that doesn't help at all. That does not help, man. Alignment procedure. Classified schematics. Oh my gosh. Oh no, this is clarified. I was like, what the? Classified? Yeah, man, these schematics are classified, bro. Alright. Man, this volume control, I'm getting hung up over this because it doesn't make any sense to me. That's what that symbol even is. I'm gonna go put my tea bag in the trash. Okay, well, don't really know what's going on here. But it's okay, I don't really pretend to know. I don't pretend to know. Okay, well, I'm giving this my best shot. Okay, that's so strange to me. Huh. Well, I think I've done my best. I guess I could just measure it, right? So... the 47K apparently goes to the pot midpoint, which is... like, it would be like, what, 1.5-ish K from the rest? Let's see. So 2.5 would be 1.25. 1.25 mega ohm. Which this chair could go higher. But alas, it cannot. Good gracious. It's sticking. We got 0.85. Open circuit. It's not really great. Oh wait. Yeah, no open circuit. That's awesome. $390K. Alright, I'm gonna go back to alligator clips because I need to clip onto this and then turn it at the same time. So we're gonna go ahead and I'm gonna unplug these. Okay. All right. So now I can go ahead and turn this. Oh, there we go. Now it's on. Yeah, it's about 700K, and it doesn't change. So that must be the midpoint of the potentiometer, which is strange. Okay, I guess I could just flip onto here. $711K. Oh yeah, no, that would make sense why this one would change. Never mind, I'm stupid. Let's go to the bottom one. The bottom one, is that ground? No way. It is. It's ground, guys. Wow, alright. Can't believe. Okay, 441K. And yeah, it's pretty constant. 442K. So wait, so we have 440, 441, and 570. Or sorry, 711. 711? Really? So 710, 711, let's say. And we have 442. Now, that would be 1.150? 1.1 mega ohm? $440 plus 710. Yeah, it's like 1.15 mega ohms. I might mark that in my schematic. It's actually pretty important. Okay, but then if we do something like, you know, take the middle wiper here and okay, well that's at one extreme. Am I crazy? Hello? It's shorted. Oh, I'm stupid. The thing is lying against it. Never mind. I was like, what is going on? Alright, well, let's turn it to one extreme. You know, anywhere from... Oh. Oh, no, it was there for a second. I saw it. 1.1. Okay, well, at one extreme, it's like 500 something K. I mean... Yeah, here we go. That's like basically one extreme, 1.1. Then we turn it down. $18 ohms, okay. $82K. It's not linear. That's for darn sure. I'm not about to put that down. Nine mega ohms. Okay, it's off the charts. It's kind of messed up now. I'm on the middle wiper, right? I don't have that marked in my schematic yet. So for all I know, it could actually be working, and I just, like trying. Okay, let's see. Middle wiper is... It should... Yeah, no, you know what? It is. It's separated by a capacitor, so it can't even be leaking DC. Yeah. Oh, I just realized I have the text up in my thing. Let me just put that back. Okay. Alright, so I'm not really sure. It has to be blocking the DC, so it must be the potentiometer is out of spec. Because I don't even have it in my schematic yet. Yes, it seems like that would be the case. It's weird because I replaced it with 0.1. But I don't even have that marked. Let me go back to KiCad and double check. Yeah, I might as well do that, right? It's also I'm gonna put 2.5 M, and I'm gonna put like 1.15 M question mark, because like I have no clue. Should put this here. I think that looks better. Okay, so let me put that back in the schematic. I don't even know what this thing is here. Okay, what is this? Yellow, orange, green. What is that? Yellow, orange. You sure it's not green, orange, yellow? Yeah, I am. Yellow, orange, green. That would be like what? 3? No, 4. 43. Or sorry, 4.3. 4.3 meg? Is that real, chat? Actually, it does attach up to the 6SA. Is that pin 8? No. Wait. What tube is this? What tube even is this? That's the question. That's the $1 million question. I wish I wrote down where the tubes went, because I don't remember now, and I don't have the tube chart anymore for some weird reason. It's not in here. Like it would have been... Oh no, I do have the tube chart. That's right, it's on the bottom of this. Right. Oh, it's 50 watts. That's what the radio is. That's the 25L. The one below it is the 6S8 GT. So I was right. It's the 6S8 GT. But it is pin... It actually might be pin 8. I'll have to figure out where the spring connects in. Oh, you know what? That's where it connects in, right there. That's probably ground. It is. Okay, so yeah, it directly connects over there, but then we have this... Oh, it is 47 meg. I thought it was orange. It's such a faded pinkish purple. It is 47. It's like 43 mega ohm is not a standard resistance. Like even for this era. That is crazy, guys. That's crazy. Yeah, so it's this one. 4.7 meg to ground, though. Doesn't look like it goes to ground. It looks like it goes to, oh, well, that pin on the tube socket is ground. Alright. So we know all of that. So I'm going to update the schematic. This saxophone player is amazing. Alright. Sorry, I need a capacitor. U. Paste. It's going to be 1 nanofarad. And it is going... How do I rotate R? Yes. Okay, this is going to go up to pin 8. Or, I guess the cap, right? No cap, bro. I'm gonna actually move this up so it's a little bit easier to follow. Actually, like this. Oh wait, I'm sorry, I'm sharing the wrong thing. You can't even look at me work. Oh shoot, I remember there being a problem with this. Well, that's good enough. Is it good enough? Oh, how did I fix it there? What? It was kind of is off center, like ever so slightly, you know? It's like, oh man. Oh, darn it. Oh, right, that's how I did it. Right, because this, okay, so last stream I wasn't on Linux. Last stream I was on Windows. And I was on a different, same laptop, different OS, and I had KiCad set up, so I was, not... Okay, someone tell me how to, how to adjust the minimum scaling distance. Or you know what I mean, like the minimum, grid 50. Yeah, grid. How do I adjust the grid size? Surely it's not in preferences. Grids. Oh, maybe it is. Oh, there we go. Fast grid switching. 25 mils. Alt 2. No. Oh wait, hang on. How did I do that? Grid 2. Let's do 10 mils. Man, it's still not giving me the prompt to connect the wire. It's so annoying. This one is, and this one's not. Do my thing here. Neither is that one. I think it has to be 5 mils. Keep making it smaller and smaller. I can't make it any smaller. Oh wait, no, I can. 5. Oh, I didn't set it up. My bad. 5 mils. Oh, I'll move this down one. There we go. Oh, that's my windows. How does it... Oh wait, it's not even doing it for the wires. Oh my gosh. Grid overrides. It's not turn off the wire override, huh? Well, I might actually only be 5 now. Let me turn back to 10. 10 mils. 10 mils. Okay, let's undo that, then that's probably easier. Oh, okay, is that right? No. Surely not. No, it's not. Okay. I was like, that makes no sense to me. Okay, it does have to be 5. Yeah, alright, whatever. Not the end of the world. Even though it kind of is. Alright, on that. There we go. Alright, perfect, beautiful, kind of, not really. Alright, let's switch back to 50 mils. There we go. Now, if I make a wire here... Okay, yeah, it does. Alright, awesome. Okay, so we do that. We got the 1 nanofarad capacitor going where it should go. According to this, it is 0.1, and then if I look over here, it should also be 0.1. 103 is wait, 103 is... Oh my gosh, I'm so stupid. 103 is 10. 104 is 100, 102 is 1. That should be 10, right? 0.01 microfarads. 0.01 microfarads, yes. All right, then we have 4.7 mega ohm to ground, and I did double check that. That is correct. That is correct. I'm going to copy and paste this. But this is a 4.7 mega ohm to ground. All right, there we go. That is volume control done. 3 cheers. And it's so hard to like actually put this chat pop-up window anywhere. So yeah, volume control is now done. I do still have to go to the other parts of the circuit though, and kind of like relearn all this, so that part's done. All right, the cathode. We got 40 and 150, and those are in parallel. Okay, we do know where our 40 is. Our 40 is here. Now I'm going to get the lighting set up just right again. Okay. Right, so our 40 is this guy here. And I am going to actually, instead of messing around with this light, I'm going to go find a pen light to use. I know we have them. They keep appearing and then disappearing. Man, I just thought we're running out of pen lights. So sad, so tragic. Oh, this is one that probably works. If it had batteries, that is. Oh, this is one that does. There we go. Here we go. All right, I can actually look at this now. So that spring is in the way. I see. It goes to here, which is attached here. I'm gonna quickly ohm that out. Okay, and it's connected, so that is correct. This is pin 8 of the audio output tube. Excuse me. Oh my God, audio amplifier output tube. Yeah, okay, that's right. There is a 150 ohm resistor that also goes to ground. I kind of drew it in parallel here, which was like a really big mistake, I guess. I guess you can say that. So probably the 150 ohm resistor is probably here. Oh yeah, it's this thing. What is that? My gosh, it should be red. Oh, brown, green, brown. No, that is 150. Brown, green, brown, 150 ohms. I mean, I could just measure it. Oh, 174 ohms, so it's slightly gone up in value. But yeah, that's 150. It's marked on my schematic, so that's all very well. Very nice, very nice. We've got 500 picofarads. To pin 6. 500 picofarads from pin 8 to pin 6. Which is this thing here. Yeah. I see. It's this mica cap. Solar cap. Okay, that's all well and good. We also have this one should go back up to pin 3, which is the plate. And by this one, I mean this wire here. This red wire. 1. I don't know. To me, it looks like it goes to pin 4. Did I make a mistake? One is grounded. Pin 1 is grounded. Pin 1 and 2. No. Pin 2 is the heater. Pin 3 should be the one connected to the other cap. Oh, wait, no. No, that is right. That is pin 4. It is pin 4. Pin 3 should be connected to this other wire. So this is the one that comes I think all the way around. Yeah. Yeah. Okay, it is. It is. That is correct. Okay. Yeah. All right. And then what this other capacitor. Like, wait, what? Huh? Okay, sorry. Oh, I see. Do I see? Actually? Wait. Right. Okay, so you have one of those sides there, the other one side goes to there, which then goes to there, which then goes to there. Okay, I do see. Um oh ho ho Oh, you know what? I am a fool. Turns out that does interfere with that. You have a 4.7 to ground. Well, after the capacitor. It is after the capacitor, not before the capacitor. I have made a mistake on my schematic. And I ask for forgiveness. This needs to move up to here. All right, I'm gonna put a ground here. There we go. Okay, there we go. So now we have that grounded. Okay. That's more like it. Okay, I'm still confused though. Not really. I'm just trying to process all of this. Huh. All right, so we have that. Okay, all of that makes sense. I got all of that. I was up through here. That's okay. Let's look at this network here, right? So we got a 20 nanofarad and a 470K to ground. A 470K. Yep, that is correct. Wait, what? Wait. Oh, wait, this might be it here. Yeah, 2020 nanofarad. This is the grid. This is the grid coupling cap. Okay. This makes so much more sense. Right, so you got it from here. We got it from where? 500 picofarad. Why is this? Oh yeah, I see. Okay, so that goes directly to the grid, the first grid. The 470K just goes directly to ground. Let's just make sure this is ground. Should be. There's no world which is not ground. Okay, maybe it isn't. Wait, yeah, maybe it isn't actually. It's going to be this one here. There's so many 470Ks. It's that one. Okay. So then that leaves. So this is okay. So this is where I want to do a poll. And if there's anyone in the chat tuning into the stream, do I go ahead and replace the grid coupling capacitor, even though it checks out totally fine? Oh, my music stopped. Shoot. That's the question, right? Do I go ahead and replace it? It checks out fine. I leak tested it. It doesn't leak at all at applied voltage. It measures perfect. And it's also an original part. It wasn't ever replaced before, which is really strange. Do I replace it? That's the question. I have no idea. I mean, okay, I actually do have an idea. Part of me thinks, yeah, I probably should. But, part of me, oh, there's no one on the screen right now. Okay. I don't know whether I should replace that capacitor or not. All right, I'm gonna decide later. I'm just gonna push this on to later me problem. That's how I deal with stuff. Okay, so now we have the second grid, right, which is attached directly to the P plus. Okay, then we have 100 and 470, and then a 50 in between. The 50 goes to ground. Wait, where is this 50? Okay, so I see the 470, and then the other thing. Oh, it's this one. Okay, so this is the 50 to ground. Ugh, balls. Okay, this is the question. It's like whether or not we can even replace these. Should I replace it? That's the question. Do I even want to leak test them? Well, I mean, okay, this one right here is going to be a royal pain. It's also probably not good. If I had to guess, I'd probably say, yeah, it's probably bad. Okay, so all right, let me just look through these components. We did not account for this. That's a tone control thing, which I'll get to in a second. The components over here, we've accounted for that one, that one, that one, that one. Sorry, I'm not on the overhead view. Alright, we've accounted for those three resistors, this capacitor, that capacitor, microcapacitor, other microcapacitor, that 150 ohm resistor. I say most of the stuff in this area is okay, or has been mapped in the schematics. It's actually so dense. Like, this is probably the most dense part of the entire circuit right here. Oh shoot! How long has that been like that? That is so unlucky. Oh, I'm so sorry, guys. Yeah, stupid. Alright, please don't crash the stream. My capture card died. Okay, we're back. How awesome. Wait, okay, are we back? Are we dropping frames? What's going on here? Sorry, guys, I'm trying my best. Sorry, I just also realized I need to... Okay, are we dropping frames? That's the million-dollar question. Sorry, guys, I'm trying my best. Sorry, I just also realized I need to... Okay, are we dropping frames? That's the we are dropping frames. Question. Sorry, guys. Okay. Hang on. Okay, good gracious. Is not happy with my encoder settings. Why does this have to happen now? Why does this stream have to break 3 hours in? I have no idea. Why? Why does it have to break now? Crap. All right. Sorry. Okay, so this is you're gonna see a little black screen, and then I'm gonna put the video capture device back, and we're gonna do this. Okay. Okay, well, I don't know. Okay, I'm going to try this again. Oh, it's so annoying. Well, I'm going to spend all day trying to fix this. Well, for I guess for the next hour or however long it takes for my OBS to get it together, you're gonna have some drop frames. Not really a ton I can do about that at the moment without restarting the stream, I think. Oh man, that's annoying. Okay, anyway. Let's go back to looking at this. So this one is okay, so basically everything here has been accounted for. The other side of the antenna is on this, which is interesting. It's okay. So that's well and good. We got, okay, so on the same pin that we're attaching the grid, no, yes, the grid coupling cap, we have a 0.003, so a 3 nanofarads attached to one side of the tone control. Now let's see how true that actually is in reality, excuse me. In reality, yep, we do. Wow, that's like exactly true. It's so weird looking at the schematic because I'm like not used to it at all. Grid coupling cap is here. Wait, 150? I see 100. Wait, what? 150 wire wound. Oh, sorry, no, 150 wire wound. Right. Okay, that makes sense. 470K. 470K. Is this ground? No, this is 100 volts. Okay, anyway, we have 62 volts in the plate. We come down here. 470. All right, sorry. No more music, guys. My earbuds have died, unfortunately. Hopefully that's not going to break all the audio when I disconnect them. Nope, we're still good. So let's see here. We have got 470 and another 4. Yeah, okay, that's the plate. All right, well, that's the tone control. That's the grid coupling. So yeah, this is okay. Normal, high, low, right? So it's just about which one gets connected to ground, I think. Is that how this switch operates? And can I replicate that within KiCad? Okay, no, so it's not. So in this one, there's only two positions. There's completely disconnected. Oh, that's interesting. That's ground, okay. There's like either you float it or you connect it. You connect it to ground or float it. That's literally the only two things. Okay, so it has one tone control, either on or off. That's incredible, really. Right, this is to tune. There's no tone control here, is there? One of these is the channel selector that I can't even toggle because it's so like tight. Okay, yeah, this is the channel selector, which also moves the needle, which is sad. I guess it wouldn't in reality, but yeah. All right, that makes sense. Okay, so that makes more sense to me. Huh. Maybe YouTube can stop dropping my frames anytime now. I've already double checked. We're on 6,000 bitrate, which should be completely fine, but nope. It has decided to be. Ooh. Oh man. I guess I could turn the encoder down. Let's see, is this gonna work? Sorry guys. I've broken everything. YouTube is being a right pain in the ass right now. Oh, that fixed it. Awesome. No, we're not dropping any more frames. So, hell yeah. No, we're not dropping anything, actually. Our capture card completely stopped working. All right. Have a problem now. I don't know. Did we fix it? No, we didn't. Okay, I give up. My encoder is still overloaded, apparently. Really annoying. Okay, well, I don't care. I don't have all time to fix that. Okay, so that's all fine. We have one side connected there, so I'm gonna go ahead and mark that down on our schematic. From here to the tone control. Now, I do not have a tone control thing put in place because it's literally just a switch. So I'm going to put it, whoa, okay, I'm going to put it, where should I put it, guys? Let's see. Add a switch. Actually, wait, there is a switch. I have it. Power switch. Copy. Paste. Hmm. Yeah, sure. You know what? Why not? Making this look very nice and tidy. Beautiful. All right. Now this one is 3 nanofarad, which is always a great value. And this is a tone switch. Boom. All right. So we got 3 nanofarads, tone switch. I'm going to just double check that they do spawn from the same point, and also I can make this a little bit more succinct like that. Yep, okay, pin 6. Very nice. Or I guess pin the cap. Pin the cap. Oh wait, oh my gosh. No, I'm wrong. I'm totally wrong about all of this. And I'm mad too, no. Alright, there we go. It's here. It's from pin 6, not pin cap. Okay, there we go. 3 nanofarads, tone switch. Boom. All right, so that is all that we really can say for certain. So I need to write down a list of capacitors to check. This one, this one, this one, and this one all need to be checked. Those are all written down on the schematic now. I guess we can just go from here, right? So let me grab my flashlight and we'll see what else is next. We got the filament pins, that's right. We got the cap. And there's nothing else connected to the cap. It just comes with this plate, volume control right there. That's to ground. We all know that. Let's see. Pin. Right, that's that pin. What is pin 1? Pin 1 on this. Let's look at it. It is the one of the plates, apparently. Pin 1. Oh, this is not helpful at all. It's this one here. Okay, that actually makes a ton of sense. Okay, this looks like it goes directly to an IF transformer. All right, let me prepare to look at that. So that's this. Where's my pointer? I keep misplacing my my screwdriver pointer thing. Oh well. Oh no, here it is. All right, so that's this one here. Pin 1. Now I think the striped wire. Yeah, it does. It looks like it goes right to this IF transformer. This is the output. So these are the input, I guess. Input, output, same thing. Really, when you think about it. Okay. So I don't know how to really mark an IF transformer on my schematic. I gotta be real honest with y'all. But it does look like it is this one. So that's interesting. We got this one and this one as well that go to two sides of an IF transformer. The output of this one. Okay, actually, no, it gives me the wire colors. White, gray, white, brown, red, black, white, black. Okay. Red, black, unintelligible, because it's so crusty. Okay, let's see. Then we have pins 4 and 6, which both go directly to an IF transformer as well. Or sorry, not pins 4 and 6. Four and 5. Yeah, this is where it becomes a little bit tricky. We have that one. Okay, well, the cathode is grounded. Let me just check that. What is that, pin 2? What is that, pin 2? That's this one here. Yep, it is. I'm going to just double check. Okay, well, cathode's grounded. That's awesome. And what else? What else? What else? We want to do... the rest of these are the plates. Right? You got your... The cap is the grid, I forgot. And then the rest of these are plates, right? So you got your all the diodes. Yeah, your heater, you got your cathode, your common cathode for everything. And then Huh, okay, this thing is kind of a freaking pain to look at. Okay. This one here, the heater pins are 1 and 2. Which makes sense, because 1 is what grounded, probably. And 2 is the heater. Heater. 3 is the plate. Right, we know that. 4 is this one here. And then this one goes right to here, right? So this is pin 2, 3. Pin 3 here. I'm sorry, pin 4? No. That is right. Pin 3. And the next one goes to pin 4. Sorry, pin 6. Am I okay? I can't read. Apparently. No. Is the schematic wrong? Pin. Man, this is a little bit annoying. Just a little bit annoying. Okay, so this one here. All right, we got heater. Yeah, ground, heater, or other side of heater, plate. This thing, which goes to pin 4. This thing, or pin 3. This thing, which goes to pin 4. This thing, which goes to pin 6. And all that is correct, according to the schematic. Then we've got a grounded cathode. And finally, this wire, which goes all the way over here to... It's not marked. It's the third IF transformer. And it looks like it's supposed to be the white-gray wire. To me, it's the white-green wire. I do not see how that could be white-gray, or gray-green even. Okay, that makes total sense. And then this third IF transformer, let's take a closer look at that. Right, so how many inputs, how many wires does that have going to it? We got red, white, black. Don't know. I don't know. Yeah, red, white, black. You know, 1, 2, 3, 4, 5, 6. 6. And on the thing, there are 1, 2, 3, 4, 5, 6. So all of this looks like it's okay. Yeah, all of this actually looks okay. Surprisingly enough. Wow. Okay, I am like shocked at how oh man. Okay. So now that I kind of know where I am, the next step in KiCad would be to design some audio out, or to do to make some IF transformers. Wow. Okay. Let me just check this schematic one more time. The cathode is grounded. That's pin what? 7. No, that's a heater. Sorry, it's pin 2. Whoops, I am scrolling all over the place. Pin 2. Oh my gosh, I keep doing the thing where I'm trying to zoom in like with like a Firefox thing, but I'm in KiCad, so it just ends up scrolling. Can I not put a wire on this? Hello? Hello, guys. I remember I did this entire design, by the way. I'm so fucking proud of it. I designed all of this. It's a custom tube, custom elements. You would never know either. Looks really good. Okay, anyway, so wire, right. I can't believe I can't put a wire here. Nope. Okay, well, I guess we're gonna just take ground, copy, paste. There we go. Yeah, there we go. Wire, done. It's a cathode. Okay, heater, we don't leave those alone. All the other pins go to IF transformers. That is something I have to figure out how to do myself. And that is going to be a future Connor problem. TM. Okay, so what have we done tonight? We've got the vacuum tubes all ready to go. We've basically we replaced we reconnected all the wires that I had disconnected previously just because we're gonna power this on and just hope for the best. I'm not gonna try to like power it up in stages. I initially thought I was gonna do that. We replaced a frayed wire. And I have gone through the schematic so far and caught myself up to date on what I did 4 months ago, which is all of this. And we've added a little bit onto this. We've identified 4 capacitors in the schematic that we think we're going to need to change. One of them I tested, it was fine, I put back, but I'm probably going to swap it anyway. Then I guess off camera, off stream on my own time, I'm going to try to figure out how to get an IF transformer symbol in KiCad. And yeah, next stream, which might be tomorrow night, I'm going to continue on reverse engineering stuff as I am able, but I said I was going to stream till 12. I'm going to end a little bit early because I'm tired, as probably was evidenced by my performance and struggling to solder 2 wires. I am kind of tired. Oh yeah, and the other thing we might need to do is we might need to back over. We might need to fix or to. I'm really scared about this electrolytic capacitor that I reformed, and now it's kind of back to where it was before. So might be a sign to just replace it, but I don't actually have any readily available replacements, unfortunately, because what is it? It's 40. It's 3 sections of 40 at like 200 or 400. No, 150. Okay, yeah. So it's 340s at 150, and I would probably replace those with 47 at 150. but I just do not have any capacitors like that. I'd have to order them. And then also this 20 microfarad at 150 is questionable as well. So yeah, basically. Don't really know, but I probably want to replace most of these wax capacitors. Even the grid coupling one that tests okay. Probably gonna just replace this one anyway. We got the 1, 2, 3, 4 that we've identified on the schematic. And then 1, 2, 3, 4, 5, 6. Wait, sorry. These 4. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. These 2 are mica, so we have 9 wax capacitors that are not marked on the schematic. We identified what might be a bad volume switch, and we added the tone control schematic, so that's kind of up to date on what I've done. It really was that we did not really get a lot done this stream, just because I need to catch up to where I was. But I think that's everything that I wanted to go over tonight. I was kind of hoping to replace some capacitors, but technically I could, but the thing is I would have to test them first, just because it's like I want to see how they are. And next stream I'll have my capacitor voltage testing set up, ready to go. Okay, whether or not I'm going to stream tomorrow night, I actually don't know. It depends on if I finish homework for my college class, and also whether or not I get enough of my PhD research done tomorrow. That is going to be tricky because people have queued up the campus HPC for quite a long time. So believe it or not, I don't just do tube stuff. I'm doing a PhD in applied science. So I'm working with AI and computers and stuff, which actually is more of what I started this channel with, but I'm getting into tube stuff, which is fun. Anyway, that's all for tonight. I'm going to end stream. Whoever's watching, have a great night, great rest of your night or day, depending on where you are. And yeah, I hopefully will see you all tomorrow. No promises though.